So you take your input, very large input or very small input, and if your output, f of x is the output, if it approaches to some number, then y equals to b. Y equals to that number is a horizontal asymptote. It is a horizontal line. Okay. So for example, let's have a graph here. We have this graph here, and let me call this is -3. So we have horizontal line at -3. Now what happens as we take our x to be big X, okay, if we take our input to be large input, now the function value, the output is very close to this line, the output is very close to this line, or output is very close to -3. So y equals to -3 is a horizontal asymptote. Okay, or we can also have, we take a very small input and our output is very close to some number, then y equals to that number is a horizontal asymptote. The next we had vertical asymptote. Okay, vertical asymptote is a vertical line, so it's a vertical line. Okay, if for some number, let's say x equals to a, so let's choose our a. So for some input a, if our output f of x approaches to very big number, positive big infinity, or f of x approaches to very small number, then x equals to a. This is a vertical asymptote. So you choose your input. Okay, you have a x inputs a. Okay, in a is any number, and when you choose that input a, if your output is very big or undefined, okay, big means undefined, if your output is undefined, then x equals to a is a vertical asymptote. Okay, and we know how to find this vertical asymptote and horizontal asymptote. In order to find the vertical asymptote, we look for the number, we look for the value of x for which the function is undefined. Okay, now let me take a function f of x equals to 1 over x minus a. This is a rational function. To find its vertical asymptote, we find a number that make denominator equals to 0. Now for this function, what number makes denominator equals to 0? 1, right? When we choose x equals to 1, our denominator is equals to 0. So x equals to 1 is the vertical asymptote. So you find a number that make denominator equals to 0 and make sure you write down x equals to that number. And those are the vertical asymptote. And in order to find the horizontal asymptote, we have a 3 condition. We need to check the degree of numerator and degree of denominator. Okay, if the degree of numerator n is greater than degree of denominator m, then our horizontal asymptote is always y equals to 0. So you have the degree of numerator greater. Okay, is that the one or is the other way? Okay, it's the other way. Okay, now for the same function, the degree of numerator, okay, if the degree of numerator is less than degree of denominator, then the horizontal asymptote is always y equals to 0. Okay, like for this function, for the same function, the degree of numerator, it is a constant, and constant has a degree 0, and this is the denominator, this denominator has a degree 1. So here the degree of numerator is less than degree of denominator, and for this function horizontal asymptote is always y equals to 0. Now next, if the degree of numerator is equals to degree of denominator, so we have a same degree in the numerator and denominator. In this case, the horizontal asymptote is every time y equals to, okay, because horizontal asymptote is a horizontal line. So make sure you write down y equals to a. A is the coefficient of leading term in the numerator divided by b. B is the coefficient of leading term in the denominator. That is the horizontal asymptote if the degree of numerator and degree of denominator equals to each other. And the last condition is that if the degree of numerator is greater than degree of denominator, then there is no horizontal asymptote. Okay, so if the degree of numerator is greater than degree of denominator, then there is no horizontal asymptote. But in our last example for this unit, we will see, so if our degree of numerator is greater than degree of denominator by 1 degree, then we find a slant asymptote. Okay, so we'll be doing that as our last example for this unit. But right now, so this three condition: if the degree of numerator less than degree of denominator, y equals to 0 every time. Okay, if it's equals to each other, then y equals to a over b. A is the coefficient of leading term in the numerator, b is the coefficient of leading term in the denominator. Okay, so this is what we did yesterday. Now let's go ahead and continue our section 3.6. And now here we will graph the rational function. So very first step is that whenever we are graphing a rational function, we need to find the vertical asymptote, okay, and indicate them on the graph. Similarly, we need to find the horizontal asymptote and indicate them on the graph. Now let's do that for this example. So we have this example here. We are trying to graph. So in order to graph rational function, we find vertical asymptote first, okay. And for this function, so finding vertical asymptote means we are finding x such that its denominator is equals to 0. Now for what x value the denominator is equals to 0? So for what x we get denominator equals to 0 here? 1. Do we have any other? -1, right? So when we choose x equals to 1 and x equals to -1, then our denominator is equals to 0. So the vertical asymptote is x. Make sure you are writing x equals to the number that make denominator 0, which is 1, and the next vertical asymptote is x equals to -1. Now let's draw a graph along with. So here let's draw this vertical asymptote. So we have x-axis, y-axis, origin. So we draw vertical line at 1 and -1. So we have 1 here and we have -1. So let's draw vertical line at 1 and vertical line at -1. So this is the very first step when you are, yes?
Are the asymptotes, are they a solid line or a dash?
It's a solid line. Okay, I mean you can use the dash. So vertical asymptote is just it's a vertical line, and for that you can use a dash line or a solid, it does the make. Okay, but whenever you see a vertical asymptote, you should know that that number is not a domain for the function. Okay, like for this function, 1 and -1 is not a domain, right? So vertical asymptote tells us that that number is not a domain. So you can use a dash line or a solid line, it does not matter. Okay, so this is our vertical asymptote. So this is our x equals to 1 and this is our x equals to -1 line, right? Now the next we find the horizontal asymptote. So let's find horizontal asymptote. And in order to find horizontal asymptote, we need to know what is the degree of numerator. We need to know what is the degree of denominator. So this is our numerator, x plus 2. And what is this degree? So degree is the highest exponent of the variable, right? So this x has a degree 1. This 2 constant has a degree 0 and the highest degree is 1. So the 1 is the degree of numerator. So 1 is the degree of numerator. Similarly, we have this as our denominator. Okay, and what is the degree for this denominator? Is 2. So 2 is the degree of denominator. The reason is that this x has a exponent 2. This one has a degree 0 and the largest is 2. So we take 2. Okay. Now, what is our condition? The degree of numerator is less than degree of denominator. And if that is the case, what is our horizontal asymptote? If the degree of numerator is less than degree of denominator, then y equals to 0 is always horizontal asymptote. So for this function, horizontal asymptote is y equals to 0. If the degree of numerator is less than degree of denominator, y equals to 0. And let's draw that. So what is y equals to 0 line here? It's a horizontal line. And do we already have that line or we need to redraw? Or we need to draw here? So y equal to 0 is x-axis. Okay, so we already have x-axis. So this is our horizontal asymptote if you want to redraw. Okay, so this is our y equals to 0. and y equals to 0 is same as x-axis. Okay, so this is our second step for drawing a graph for a rational function. Now let's go to the next one. In step 3, we find the x-intercept and y-intercept and plot these points. Now for this function, our function is, let me write down, our function f of x is x plus 2 divided x square minus 1. Now for this function, let's find x-intercept and y-intercept. Now what does it mean by finding x-intercepts? So we are finding a point where a graph crosses x-axis, right? And every point on the x-axis has y-coordinate equals to 0. So what do we substitute for x-intercept? We substitute y equals to 0 or f of x equals to 0. In order to find x-intercept, you always substitute y equals to 0 or f of x equals to 0. Now let's solve this. So we have 0 equals to x plus 2 equals, so over x square minus 1. Now how do we get rid of this denominator x square minus 1 from right side? So we multiply both sides by the denominator. Our denominator is x square minus 1. So let's multiply both sides by x square minus 1. X square minus 1, x square minus 1. So this cancel. Okay, so 0 times x square minus 1, that is 0 equals to x plus 2. So we subtract 2 on both sides and we have negative 2 equals to x. Okay, it means what is our x-intercept? Negative 2, 0. So negative 2, 0. So this is our negative 1. So let's say this is negative 2. So this point is negative 2, 0. So this is the x-intercept for this function. Okay. Now let's find the y-intercept. And how do we find the y-intercept? So how do we find the y-intercept? And what does it mean by finding y-intercept? We are finding a point on the y-axis, right? And every point on the y-axis has an x coordinate equals to 0. So we substitute 0 for every x in the function. So let me write down function one more time. F of x is equals to x plus 2 divided x square minus 1. So let's substitute 0 for every x. So you substitute 0 for every x, okay? So for every x, you're going to substitute 0. So f of 0 is equals to 0 plus 2. 2 divided 0 minus 1, minus 1. So we have negative 2. So our y-intercept is at negative 2. So negative 2 is somewhere here. Let's say this is negative 2. So this is our y-intercept. So you find the vertical asymptote, you find the horizontal asymptote, then you find x-intercept. If you have, you find the y-intercept. Okay. Now, so next here, so once after that, so we have step 4. Now, so using 1, 2, 3 step, we draw partial graph, and yeah, we can just find some few more points. Okay, so we have 2 points here. So we have x-intercept. So this is the point, and we have this point here. Let's find some more points. Okay, let's make a table here and find some more points here so that it would be easy for us to graph a function. Okay, now let's make a table here. So x is the input, f of x is the output. Okay. Now let's choose a x. I mean, we can choose any x other than negative 1 and positive 1. Okay, let's see what happens on the right of this vertical asymptote. So let's choose a number like negative 3. So what happens if x is equals to negative 3? So if x is equals to negative 3, what is our output? Our function is x plus 2 divided by x square minus 1. So you substitute -3 for x. So we have, so what is the output do we get for this function? Okay, let's see. So our function is f of x equals to x plus 2 divided x square minus 1. So we substitute -3 for every x. So -3 plus 2, that is -1, right? Divided by -3 square is positive 9. 9 minus 1 is 8. So we have -1 divided by 8. So we get, so -1 divided by 8. What is, can anyone help me? What is -1 divided by 8 here? So negative 0.125, okay. Okay, now let me choose a number. So this is -2 here. So this is -2, and this is our -1. So let me choose like between, so 1.5, like -1.5. You can choose any number, okay? So -1.5. So if x is equals to -1.5, then we have 1.5, -1.5 plus 2, that is positive 0.5, and divided by -1.5 square, that is it 2.25 minus 1, 1.25. So 0.5 divided by 1.25, okay, we get positive 0.4, okay. So 0.4. Okay, now let's see and draw some part of graph here. Okay, now for this function, can we choose any number less than -1 or not? So for this function, we can choose any number on the less than -1, right? It means our graph is extended all the way to the left. So when x is -1.5, we have 0.4, let's say somewhere here. When it's -3, so this is -3. So this is -3, this is -2. When it's -3, we have -0. Okay, somewhere here, right? So let's make a graph here. So we can extend. So this is, since this is the x-intercept, so it does cross the x-axis, right? Now, can we cross this vertical line when we extend on the right side? No, right? This is a vertical asymptote, and when you have the vertical asymptote, your graph is blocked here. It means you extend your graph all the way to the positive infinity or negative infinity. So we can't go on the right of, we can't cross the vertical asymptote, okay? At vertical asymptote, our function is undefined. So this is one part of a graph here.
So what about the horizontal asymptote y equals 0?
Okay, now here, it means when we extend our graph on the left side, so when we choose very small number, our f of x is very close to 0. So if we go all the way to the left, then this graph or the output is very close to 0. Like when we choose -1.5, see, when we choose -3, our output is -0.125, which is very close to 0. Okay, so whenever you have the horizontal asymptote, means when you choose your input to be very small or very large, your output is very close to 0 in this case. Okay, so when we choose, like, okay, let's choose like -100. When you choose x equals to -100, your output is very close to 0. It means when we extend this graph on the left side, this graph is very close to our x-axis. Okay, and here you don't want to be very precise. Okay, if you have a close enough, then it's good. So whenever you have the vertical asymptote, never cross the vertical asymptote. Okay, because at vertical asymptote, function is undefined. And whenever you have the horizontal asymptote, your output is very close to that horizontal asymptote. Okay, so when you extend this graph on the left, this graph is very close to our the very close to our x-axis. It never crosses x-axis, okay? It never crosses x-axis, but it is very close to our horizontal asymptote. Okay, it never tosses. It never cross our x-axis. Now here it doesn't matter what number you choose on the left. This line, this graph is very close to your horizontal asymptote. Okay. Now let's see what happens in between these two vertical asymptote. So we have these two vertical asymptote. Okay. So we have these two vertical asymptote. Okay. Now let's see what happens in between these two vertical asymptote. Okay. So now let me choose a number somewhere here. So this number is, so this is our 0, this is -1. So let's choose -0.5. So if you choose your input to be -0.5, so what happens to the output? So we substitute -0.5 for every x. So -0.5 plus 2, that is positive 1.5, divided by -0.5 square, is that 0.25 minus 1? So do we get negative number? So we get something negative, right? So do you have exact number?
We get -0.75.
Okay, -0.75. Okay.
Oh, wait, 0.75 and then 1.5 over that, which is -2. That's what I got.
So is the, okay, so give me a final answer.
-2.
Negative, okay, -2. Okay. We don't get -2. The reason is that if you see, when our input is 0, we had a -2. But do we get the same output when our input is -0.5? Let's see one more time, okay? So here, so we have -0.5 plus 2 divided -0.5 squared minus 1. So this is 1.5. -0.5 square, is it 5? That's 25. Is it 0.25 minus 1? Okay, so we have 1.5 divided by, this is -0.75. And what is 1.5 divided by -0.75? Is it -2? Okay. But when our x is equals to 0, we had a -2. Okay, let's see. So we can't, so we have a different input. Okay, is our y-intercept incorrect then? Let's see. So when x is 0, we have 0 plus 2 divided by 0 minus 1, that is -2. And when we choose -0.5, so we have -2. Okay. Okay, let's see. But this is not supposed to happen here.
Isn't it because it's a parabola, so it makes sense that it's the same?
So we have okay, let's plot that point. Okay, let's see. So if we plot that point, so we're gonna have somewhere here, right? The point is over here. Like, so if, okay, so -0.5, -2 is somewhere here. So this is our -0.5, and this is the point, -2. Yeah, they can have the same height. That's right. Okay, so we are correct here, right? Let me know. Do you have any question here? So we get the -2. Now let's plot this point. If we plot this point, -0.5 and -2, where do we find that point? So we have -0.5 here, okay? So -0.5 here, and -2 is here. So this is the one point, okay? Okay, now let's choose something different input here. So if we choose, okay, so close to -1. Let me choose like -0.9. So what happens if we choose our input to be -0.9? Can you help me here? So if your input is -0.9, do we get our output as -5.78, something like that? So when we substitute our input equals to 0.9, our output is -5.78. So on the graph, the point is somewhere here. So let's say somewhere here. Similarly, let me take positive 0.9. If our input is positive 0.9, so if it's positive 0.9, so we're gonna have, so that's 2.9 divided by, okay, so it's gonna be a lot of calculation here. So can you help me here, like when our x is 0.9, what will be our output? So you substitute 0.9 for every x. Look, so we should have started with a very easier rational function, okay? But once we do this one, we'll just do a simpler function, okay? Did anyone have a final answer for output for 0.9? Anyone else? So you have, so 0.9 is squared, that is 0. Is it 0.81 or 0. Okay, 0.9 times 0.9, that's okay, 0.81 minus 1. Okay, so here, so our input is 0.9, so this is 2.9 divided 0.81 minus 1, so 2.9 divided that's negative 0.19, and 2.9 divided by negative 0.19. okay, help me with this one. So we get negative 2.9 divided by negative 0.19, negative 15 point something. Okay, so negative 15 point, okay, let me take this one. So we have negative 15.2 or something, and if we plot this point, the point is somewhere here, let's say, so we have 0.9 is somewhere here, right? So this is positive 1, okay, this is 0.9, so somewhere here. So we get a graph, okay? So if we connect all these points here, so we get a graph that goes like this, okay? So okay, this point has to touch here. So we're gonna get the graph like that. So it never crosses the vertical asymptote, okay? It doesn't matter, even inside, the graph does not crosses the vertical asymptote. Now we still have one more part, like on the right side of the second vertical asymptote. So this is 1, let's choose 2, and let's choose 3, and let's see what happens to the output. So when our input is 2, it's gonna be, hopefully it's gonna be easy here. So 2 plus 2, 4, divided by 4 minus 1, that's 3. So 4 divided by 3 is like 1.3, okay, 1.3. So 2, 1.3, so this is 2 and 1.3 somewhere here, okay? Now let's choose 3. So when x is 3, so we have 3 plus 2, 5, divided by 9 minus 1, that is 8. So we have 5 divided by 8, that is like 0.6 something like 0.625, okay, 625. So the somewhere here. Now as we take a very number close here, we get the output very big here. So the graph goes all the way to the, okay, let me use different, all the way here, and it never touches the horizontal asymptote, and it never touches the vertical asymptote. And we choose the difficult function here. Let me go with, I know this is a lot here, let me just do one more, okay, like the simpler one. and it would be easy for us to graph the function. Okay, let me double. Okay, yeah, you do have a homework for sketching the graph here. So let me do number 35. Okay, I know you do have a confusion here. Just let me do one more example and it should help you. Okay, so before this last example, let me do number 35. Okay, so this is number 35 from your homework. So number 35. So we are given a function f of x is 3 minus x divided x plus 4. This is the function. Okay, we are graphing this function. The very first step is we find the vertical asymptote. And what is the vertical asymptote for this function? That's not how we write the vertical asymptote. X equals to -4. Do not forget x. Okay, if you write -4, you won't get the credit. X equals to -4 is the vertical asymptote. So let's draw the vertical asymptote. So this is -4. So you draw vertical asymptote here, -4. X equals to -4. Now let's find the horizontal asymptote. And for horizontal asymptote, we find the degree. So what is the degree of this numerator? Okay, let's go one by one. The degree of 3 is 0. Degree of x is 1. And what is the highest degree? 1. So 1 is the degree of the numerator. Similarly, what is the degree of denominator? So degree of x is 1. The degree of 4 is 0. So highest degree is 1. So we have the case where the numerator degree is equals to denominator degree. And if this is the case, our horizontal asymptote is y equals to, so what is the degree, what is the horizontal asymptote here? So we have 3 minus x and x minus, sorry, was it x plus x plus 4? Okay, so the degree, so the horizontal asymptote is the coefficient of leading term from the numerator. So in the numerator, what is the leading term? Is it 3 or negative x? So leading term is the term with the highest degree. So which one is the leading term? Negative x. And what is its coefficient? -1. So -1 divided by the coefficient of leading term in the denominator. In the denominator, x is the leading term and its coefficient is +1. So y equals to -1 is the horizontal asymptote. So let's say this is -1. This is -4. So we draw a horizontal line at -1. Okay. Now let's make a table here. So x, f of x. So we're gonna have the graph. Okay, so here we're gonna have the graph here. Okay, the next is finding the x-intercept and y-intercept. Now for this function, so before that, let's find the x-intercept. And how do we find x-intercept for this function? F of x equals to 3 minus x divided by x plus 4. What do we do to find the x-intercept? We substitute 0 for y, right? So our y is 0, so this is 0, and we solve for x. So we have 0 equals to 3 minus x divided by x plus 4. Now let's get rid of this denominator. For that, we multiply both sides by x plus 4. X plus 4, this cancel. So we have 0 times x plus 4 is 0 equals to 3 minus x. And from here, x is equals to +3, right? So we subtract 3 on both sides and multiply by -1. We get x equals to 3. So our x-intercept is at +3. So x-intercept is at +3. So we have +3 here. So this is our x-intercept. It means the graph has to cross this point, okay? Now let's find the y-intercept. And how do we find y-intercept? In order to find y-intercept, we substitute 0 for every x. So we have f of 0 equals to 3 minus 0 divided 0 plus 4. So we have 3 over 4. 3 over 4, that is 0.75. Okay. So 0.75 is the y-intercept. So 0.75 is somewhere here. Okay. Okay, let me know if you have any question up to here. We find the vertical asymptote, we find the horizontal asymptote, we find the x-intercept, y-intercept. Okay. Now we choose a point. We find more points for the graph. Okay, so that it will be easy for us to graph here. Okay. Now here, okay, let's choose the input. So we want to have some part of graph on the left of -4, okay, and on the right of -4. So let's choose some number less than -4. So if let's choose like -5. So if x is -5, what is our output? So we have 3 -5, that is 8 divided by -5 plus 4, that is -1. So we have 8 divided by -1, we get -8. So we have -8. So when we choose x to be -5, our output is -8, like somewhere here. Okay. Now let me choose some small number here, like -20. So if x is -20, so we have 3 minus -20, that is 23 divided by -20 plus 4. So we have 23 divided by -16. And what is that equals to? So can you help me? So we have 3 plus 20, that is 23 divided by -16. -1.4. Okay, -1.4. So we get some point somewhere here. Okay, -1.4 means so it's somewhere here. Okay, so it means we're gonna have a graph here. So as you take a smaller number, okay, as you take a smaller number, you get the graph closer to the horizontal axis. It never crosses horizontal axis. Okay, as you take the smaller number, okay, like it's smaller than -20, like if you take -100, we're gonna get the number -1.000 some. Okay, and as we take a number closer to -4, we get a number. Okay, let me choose -4.01 or like -4.1. So what would be the output if we choose -4.1? Let's try one more. So 3 minus -1, 4.1, that is like 7.1 divided by -0.1. So what is 7 divided -0.1? Is it -70? Okay, so we have like -70. So when we choose our -4.1, so we're gonna have something point like here. So let me extend all the way somewhere here, like very here, like -70. So we're gonna have a graph. So let's connect these 2 points, and we get a graph that looks like it never crosses the vertical asymptote. Okay, and the graph, it never crosses the horizontal asymptote as well. Okay, any question up to for this part? Now we're gonna have a graph on the right of -4. Okay, so we have these 2 portion on the x-axis. So we already have the graph for this part. Now we need to have a graph for the right of -4. Okay, we know that the graph crosses the x-axis at this point and the y-axis at this point. Okay, we already know these 2 things because negative. Okay, our x-intercept is +3 and y-intercept is 0.75. So let's choose a number somewhere here, like -3.9. So let's choose so if our x is -3.9, so -3.9. Now let's find the output, -3.9. So 3 negative 3.9, that is 6.9 divided by 0.1, that is 69. So we're gonna have 69 here output. So when you choose a point X input here, we're gonna get output somewhere here. So this is 1 point. Okay, now let's choose a number, very small, very big number, like 100. So let's choose some big number, 100. So if we choose 100 for X, so 3 minus 100, that is negative 97 divided by 104. Can you help me with the negative 97 divided by 100? That's negative 0.97, right? Negative 0.97. Okay, that is negative 97 means, so we're gonna have, so let's say this is 100 and negative 0.97, this is negative 1. So somewhere here, the close to this line. So we get a graph here. So the graph goes all the way up. It crosses x-axis, y-axis at 0.75. It touches x-axis at 3 and goes all the way right without crossing this horizontal asymptote. So once you have the horizontal asymptote, so you need to choose like extremely small or extremely large. Okay, so then it will be clear, then you can get the clear graph here. Okay, so this is for our graph for this rational function. Okay, let me know if you have any question. So you need to practice here. Okay, and you can always check this with a graphing calculator. Okay, if you have a graphing calculator, you can always use graphing calculator to make sure you have the correct graph. Okay, now we have last example for this section here, and it asks us to, let me erase this part here. We won't sketch the graph. Okay, so it's gonna be tough for us, so let's not do this one, but let's find the slant asymptote. And now here, as I said earlier, so whenever the degree of numerator, okay, is greater than degree of denominator by 1, okay, by 1, then we don't have the horizontal asymptote, but there is a slant asymptote. Okay, one more time, for the horizontal asymptote, if the degree of numerator is less than degree of denominator, y equals to 0 is the horizontal asymptote. If the degree of numerator is equals to degree of denominator, then y equals to coefficient of leading term from the numerator divided by coefficient of leading term in the denominator is the horizontal asymptote. If the degree of numerator is greater than degree of denominator, then there is no horizontal asymptote. Okay, but here, if the degree of numerator is greater than degree of denominator by 1, then we find the slant asymptote. Slant means we don't have a vertical line, we don't have a horizontal line, we have an inclined line. Okay, slant line. So slant asymptote means you're gonna have this kind of line, so as a asymptote, and the condition is the degree of numerator has to be greater than degree of denominator by 1. Okay, now for this function here, what is the degree of numerator? What is the degree of numerator for this function? 2, right? 2 is the degree. And what is the degree of denominator? What is the degree of denominator? 1. Okay, now in this case, do we find horizontal asymptote or not? Is there a horizontal asymptote for this function? Horizontal asymptote. There is no horizontal asymptote, but we find slant asymptote. Okay, see, there is no horizontal asymptote. If the degree of numerator is greater than denominator, there is no horizontal asymptote, but we do find the slant asymptote. Okay, now to find the slant asymptote, we need to have the long division. Did we do long division? No, right? Yeah, that's right. Okay, now since we started 3.6, let me go and check 3.2 if there's so this might be the one we're gonna talk like after 3.2, because we didn't talk about the long division. Okay. Yeah, the division of polynomial is in section 3.3. So we are not doing this. Okay, so we'll be doing this after we do section 3.3. Okay, and you are not preparing this example for your exam. And if there is homework similar to this one, you are not doing that as well. Okay, so let's do this much for today. If you have any question, I'll be here a few more minutes. And